Okay, example 17. I don't believe this one is in your original set of notes. I will have um, put this in for you. You'll just need to get into Schoology and grab it, or you can write it out. So you can either print it off if you have that capability and add it, or you can write it up in your notes. Okay, once again, we are establishing whether or not we have the ability to get concentration given straightforward concentration or given straightforward pressure. So pressures will be given to you straightforward. You may have to do some extra work to calculate concentrations. And it looks like we have an ability to get concentration. So we're going to figure out what our concentration is for HOCl. We need to know what our concentration of H2O is. And we need to figure out, have either an unknown or either, let me try that again, not an unknown, either an equilibrium or an initial value of all three of these to be able to do these problems. So I see initially there's 1 gram of water, 4.82 grams of ClO2 are mixed in a 3 liter flask. Calculate all concentration of all species equilibrium for each component. Okay, so we can say that we have 1.00 grams of H2O, and we know there are 18.02 grams of H2O for every 1 mole of H2O. So we got to calculate what that is. So 1 divided by 18.02 is going to give me 0.055 5 moles. Then I'm going to divide that by 3.0 liters to get my concentration. And I get a concentration of 0.0185 big M for molarity. I'm going to do what I did before and move this down. Okay, so what else do I know? I know the concentration of ClO2, or I guess I don't know the concentration, I misspoke. I know I can get the concentration. I have 4.82 grams of Cl2O. I might have just called that ClO2. It's Cl2O. So I'm going to do 35.45 times 2 plus 16, and I get my molar mass, my 86.90 grams of Cl2O for every 1 mole of Cl2O. So I'm going to do 4.82 divide by 86.9, and I get this to be 0.0555 moles over 3.0 liters. So I get a concentration here of 0.0185 molar. And then I go back up here, and I have no information given about this. So we can go forward and think about what we do have. We know this is initial and initial. So we can set up our ice chart. Why do we need an ice chart? Because we do not have everything at equilibrium. Okay. So what do we know? This is 0.0185, 0.0185, and this is 0. How do I know it's 0? Because I'm not told an initial amount. Let's see what we can do further. We know this has to be plus 2x because it has to increase. They flip back and forth, so that by default makes this minus x and minus x. Again, it's plus 2x because of the 2 in front. It's minus x and minus x because by default, if one side's positive, the other side, the arrow has to be negative. So this is 0.0185 minus x and 0.0185 minus x. So my k equals 2, oh, and this would be, sorry, this would be 0 plus 2x. There's no e down here, so this is just going to be 2x. And we have 2x to plug in, because remember this, and this are all equilibrium values. We're going to square that over 0.0185 minus x. And then the next one is 0.0185 minus x. So hopefully you're seeing a pattern to this, and that I have, oh, and let's go back up. We knew the value of k up here. The value of k up here was given to us. So this is 0.090 equals 2x squared over 0.0185 minus x squared, because the same thing times the same thing is squared, so we can take the square root of both sides. 0.09 square root. This is 0.30 equals 2x over, remember I take the square root of squared, that means I get rid of the squared, 0.0185 minus x. I'm going to solve this by cross multiplying, so 0.30 times 0.0185 minus x equals 2x. So I'm going to take 0.3 times 0.0185, and I get 0.0056 minus 0.30x equals 2x. Combine like terms by adding 0.30x to both sides. So I get 0.0056 equals 2.30x. Continuing to solve for x, I just divide both sides. 0.0056 divide by 2.3, and x equals 0.0024. So now I have a value of x. Let's go back up and look what the problem asks for. It said all concentrations of all species at equilibrium in each component. So now I can do this math up here. And to do that, I am going to give myself some space up here, change colors so you can see that. So this would be for both of these, it's going to be, I'm going to do my work down here so you can see it, 0.0185 minus 0. Couldn't remember what that was, so we got that now. 0.0024. 0.0185 minus 0.0024, and I get 0.016 for those two concentrations, which would be H2O. So the concentration for H2O and Cl2O would be that. And then if I were to do this for HOCl, I would have to take 2 times 0.0024. I just want to make sure my decimals get in the right place. I am horrible with that in my head. 0.0048. So that would be my answers that I'd put. I'm going to clean this up a little bit. This would be for both of those would equal that, and that would be that.